We see more than 7 jets that are tightly collimated coming out of this object. And of course, there are 2 possibilities that we considered all along, that these jets are naturally produced out of ice on the surface of a rock. And the second possibility is that they might be thrusters on the technological spacecraft. And so how do we tell the difference? Well, if it's a natural object, then we know the temperature on the surface of a rock, given its distance from the sun, and that gives the characteristic speed of any volatiles that get sublimated and ejected from those pockets of ice. And so knowing the speed, we can see how far these jets go into the solar wind. We know the properties of the solar wind, and these jets appear to be, some of them in the direction of the sun, and they go 1 million kilometers away from the object.
Something happened 2 days ago that NASA isn't talking about, and it's massive, literally. On November 9th, 2 amateur astronomers in Europe pointed their backyard telescopes at 3I Atlas and captured something that has Harvard's Avi Loeb questioning whether the laws of physics as we understand them can even explain what we're seeing. We're talking about jet structures extending nearly 3 million kilometers into space. That's 7 times the distance from Earth to the Moon. And the math behind these jets? According to Loeb's calculations published just hours ago, there's a 1 in 100 million chance this is natural. But here's what should terrify you. While amateur astronomers with backyard equipment are sharing this data publicly, NASA has been silent since the government shutdown began on October 1st. The space agency that spent $24 billion of your tax dollars last year can't seem to find time to release the high-resolution images their Mars orbiters captured in October. So let's talk about what they're not telling you. The discovery they didn't want you to see. Frank Niebling and Michael Buchner, 2 amateur astronomers you've never heard of, just did what NASA's billion-dollar satellites apparently can't. They showed us what 3I Atlas really looks like. Using a TEC-140 telescope and an ASI camera, equipment you could buy for about $15,000, they captured 5 3-minute exposures between 5:08 and 5:22 UTC on November 9th. When they stacked those images, they revealed something extraordinary. 3 distinct jet structures. 2 anti-tail jets shooting toward the sun, extending 10 arc minutes across the sky. And 1 massive collimated jet pointing away from the sun, stretching 30 arc minutes, roughly the apparent diameter of the full moon. Now here's where the numbers get disturbing. At 3I Atlas's current distance of 326 million kilometers from Earth, those angular measurements translate to physical scales that shouldn't exist on a natural comet. The sunward anti-tail jets span 950,000 kilometers. The tail jet away from the sun, 2.85 million kilometers. To put that in perspective, this is 3 orders of magnitude. That's 1,000 times larger than the glowing halo Hubble photographed back in July. The question Loeb asked in his article this morning is the one NASA won't answer. How does a comet eject material over distances this enormous? The mass loss problem. Here's where the physics breaks down, or where someone isn't telling us the truth about what this object really is. For natural comets, gas and dust escape at about 0.4 kilometers per second, roughly the speed of sound in the gas at 3I Atlas's distance from the sun. To create jets extending millions of kilometers at that velocity, the material would need to be flowing continuously for 3 months for the tail jet and 1 month for the anti-tail jets. But here's the problem. Loeb calculated that maintaining these jets requires a mass loss rate of 50 billion tons per month. Let me say that again, 50 billion tons per month. That's nearly equal to the minimum total mass of 3I Atlas itself, which Loeb calculated at 33 billion tons based on its lack of non-gravitational acceleration before October. Think about that. If this is a natural comet losing 50 billion tons per month, it should have disintegrated by now, yet it's still here, still active, still ejecting material at rates that defy conventional comet models. unless it's bigger than we thought. Much bigger. Loeb's conclusion? If this is a natural comet and most of its nucleus survived perihelion, its diameter must be 10 kilometers or larger. But here's what NASA isn't telling you. There's not enough rocky material in interstellar space to explain how an object this massive ended up here during our mere decade of systematic surveying. Statistically, we should see a 10-kilometer interstellar object once every 10,000 years or longer. We've been watching for 10 years, and here it is. The probability of that happening randomly? Less than 0.1%. Now let's add another impossibility to the pile. 3I Atlas is traveling retrograde, opposite to the direction most objects in the galaxy orbit. That's unusual, but not impossible. What is nearly impossible is that its retrograde trajectory is aligned to within 5 degrees of our solar system's ecliptic plane. The probability of that alignment occurring naturally? 0.2%. When you combine the mass anomaly probability, 0.1%, with the trajectory alignment probability, 0.2%, you get odds of 1 in 100 million for 3I Atlas to have arrived here as a random natural comet from interstellar space. 1 in 100 million. But Avi Loeb didn't stop there. In his article this morning, he proposed an alternative explanation, one that NASA has been conspicuously silent about, despite Congresswoman Anna Paulina Luna demanding answers in her October 31st letter. What if the jets we're seeing aren't from sublimating ice? What if they're from technological thrusters? Chemical rockets, the kind we've been building since the 1940s, expel exhaust at 3 to 5 kilometers per second. That's 10 times faster than natural comet outgassing. Ion thrusters, which NASA already uses on spacecraft like Dawn and DART, reach 10 to 50 kilometers per second. At those velocities, you'd need 1 to 2 orders of magnitude less mass to create the same jet structures we're seeing. Suddenly, the fuel requirement drops from 50 billion tons to potentially less than 1% of the spacecraft's mass. And here's the detail that should make you ask questions. Those anti-tail jets pointing toward the sun? They're pushing against the solar wind, a stream of charged particles flowing at 400 kilometers per second. For those anti-tail jets to remain collimated and not be blown apart, their ram pressure must exceed the solar wind's pressure out to distances of roughly 1 million kilometers. Loeb calculated that the outermost mass density in these anti-tail jets is 1 million times higher than the solar wind density. 1 million times higher. Natural comet physics doesn't do that. So where is NASA in all of this? Silent. The space agency has had high-resolution images of 3I Atlas since October 3rd, when the Mars Reconnaissance Orbiter, ExoMars Trace Gas Orbiter, and Mars Express all had line of sight to the object during its close approach to Mars at just 18 million miles. Congresswoman Luna wrote to Acting NASA Administrator Sean Duffy on October 31st requesting immediate release of specific records, images, and data about 3I Atlas for wider analysis. NASA's response? A scheduled phone call for November 6th, a week later, and a promise to release data once the U.S. government reopens. Meanwhile, amateur astronomers with $15,000 in equipment are publishing images that fundamentally challenge our understanding of what this object is. Here's what we know NASA has but isn't showing us. Mars Reconnaissance Orbiter captured close-approach imagery in October with its high-rise camera, capable of resolving features as small as 1 meter from Martian orbit. From 18 million miles, it could theoretically resolve features on 3I Atlas down to roughly 90 meters. The Hubble Space Telescope is scheduled to perform ultraviolet spectroscopy on 3I Atlas this month to determine gas composition and sulfur-to-oxygen ratios. The James Webb Space Telescope observed 3I Atlas on August 6th and is scheduled for follow-up observations in December. That data exists. It's sitting on NASA servers, and you're not allowed to see it because of a government shutdown that conveniently began the same week 3I Atlas made its closest approach to Mars. So what happens next? 3I Atlas will make its closest approach to Earth on December 25, 2025, at a distance of 269 million kilometers. That's about 100 times farther than the extent of the jet structures we're seeing now, which means Earth-based particle detectors won't capture anything from the jets. NASA's Juno spacecraft will probe 3I Atlas on March 16, 2026, from 53 million kilometers. Still too far. But here's what will happen. Spectroscopic observations in the coming weeks will measure the velocity, mass flux, and chemical composition of those jets. And when that data comes in, we'll know whether we're looking at sublimating ice traveling at 0.4 kilometers per second or something traveling at 3 to 50 kilometers per second. We'll know whether this is a comet or a craft. Unless, of course, NASA decides that data is too sensitive to share with the taxpayers who funded the telescopes that captured it. 2 amateur astronomers just revealed that 3I Atlas has jet structures spanning millions of kilometers and mass loss rates that defy natural comet physics. Harvard's Avi Loeb calculated a 1 in 100 million probability of natural origin. And NASA, the agency with the billion-dollar satellites and high-resolution cameras, has been silent for 41 days and counting. You decide what that means.